What we're going to do today, of course, the schedule and the syllabus marks today out as a buffer day. I do believe. Yes. Actually, our last meeting was a buffer day. We covered chapter 9, chapter 5. Today, what we're going to do is start the review and finish the review next Tuesday. So we've got all of this class period that we can spend probably on chapter 4. I'm not sure yet. We may finish chapter 4 and 5, depending on how fast it goes. In which case, if we do finish 4 and 5 today, then next Tuesday, I'll be here zoomed in and in class so that anyone with questions can zoom in or come into class and ask. Otherwise, there won't be any new material covered. So let's get started with, this is the review document you'll recognize. And what I've done is I've taken each question that I think is significant and representative of the types of questions you'll see on the exam and highlighted them. So let's take them one at a time. Number 1, the symbol for the element iodine. So what we're looking at here is, do you know the symbols that I told you to memorize? Iodine's easy. But do you recognize any of those others as valid symbols? IO is not. ID is not. IN is a valid symbol, but it's not iodine. And IE is not a valid symbol. So you could get C and D confused. IN, I believe, is indium. All right. Okay, so number 2. What's the symbol for lead? This is one of those symbols that's derived not from English or anything resembling English, but from the Latin. Right? PB stands for plumbum, which in Latin means heavy. How about the other symbols? AU, that's a valid symbol. That's gold. SC is scandium. SR is strontium. Excuse me. I'm looking at number 3. Number 2, LD is not a valid symbol. L is not a valid symbol. P is a valid symbol for phosphorus. And LE is not a valid symbol. So there again, you could get P and PB confused if you don't have the symbols memorized. Now we'll go to 3. So let's see, which of the following elements is an alkaline metal? So in this case, you don't have to know just what the symbol is. You also have to know where it's located in the periodic table. Alkaline metals are the first group on the far left of the table. Any one of those would be valid for to find in this list. And you will have the review document has useful information at the back of it. And one of those items is a periodic table. The element names are not listed, but the element symbols are. And the groups are not listed. So you have to know where those groups are. That first group will include not AU, gold, that's a transition metal. SC, scandium, that's also a transition metal. SR, strontium, is an alkaline earth, second column. Na is sodium, that is an alkaline metal. So sodium is the answer for this one. And of course, the last one, CO, is cobalt. So all of those are valid symbols, but only sodium is an alkaline metal. Number 4. An atom with 45 protons has a mass number of 100. So we've got some element here that has 45 protons, right? Goes in that position, Z number, and a mass number of 100. Okay. It must contain how many neutrons? For this one, you have to know what these values are. This is the number of protons. This is the number of protons plus the number of neutrons. So if you subtract this one from that one, you'll find the number of neutrons, which is 55. 55 plus 45 is 100. That makes the answer A. All right, let's make some room now. Five. We may have introduced this, the answer to this question in the lecture. Otherwise, you'll find it in your textbook. The most abundant element in the human body is essentially the most abundant element on the crust of the earth, which is oxygen. Now, why would oxygen be the most abundant element in the human body? Because the human body is basically a big water bag. Some estimates in the neighborhood of 80%, 75 or 80% of the body is water. So since water is that, there's a whole lot of oxygen there. Now, the problem with that question is it says the most abundant. What does that mean? Does that mean number of atoms? Or does that mean mass? Now, definitely if it means mass. Number of atoms might be questionable. So, we're going to assume, for the purposes of this question, that most abundant means the most mass. All right. What's the symbol for copper? Again, that's one of those that's derived from Latin. And copper is from cuprum, the Latin for copper. Notice also, don't ever forget this, when you write a symbol, if it's got one letter like carbon, it's capitalized. If it has 2 letters, the second one is always small. If you write both of them capital, I know some students just have been in the habit over years of writing everything in block capital letters. So they will come in and write cuprum like this. Right? That's not necessarily wrong, but if you write CU like this, that is wrong. Beware. All right, number 10. An atom that has 54 protons, 54 electrons, and 78 neutrons is. All right, so we have our symbol that we don't know yet, has 54 protons, 54 electrons, and 78 neutrons. So 78 plus 54 is a mass number of 132. Now, which one of those do we need to identify the element? We only need this one right here. Right? We also know that since this number of protons is equal to the number of electrons, this element is neutral. So if we say 54 protons, that's the atomic number. We look it up on the periodic table and find that 54 means xenon. Okay, with no charge. That's why D is the answer. Now, if we had said something other than 54 electrons, we would have to put a charge up there. Let's just make something up, right? Noble gases are typically not charged unless you force them. Right? So if we force this one to lose an electron, now it has 53 electrons. That means the correct symbol has a plus charge on it. But in this case, it's neutral. So we don't need the charge. All right, number 12. How many neutrons are there in one atom of Sc scandium? Right? This is like, we've done one like this already. How many neutrons? 45 minus 21 is 24. 24 neutrons. Which of the following is a noble gas? Right? You know where the noble gases are located. Right? Far right column in a periodic table. Just find the one that matches. And it happens to be AR. Argon is a noble gas. Now we're getting into chemical formula. How to write a chemical formula. Let's see, this is 14. Yeah. The chemical formula Al2O3 indicates what? Well, I always look at the answers. When you've got a multiple choice test, look at the answers and they'll give you a clue as to what the question is looking for. In this case, it's looking for atoms of. Right? So if this were a single formula unit, what it's saying is that the ratio of these two together is 2 atoms of aluminum for every 3 atoms of oxygen. Right? Oh, we have to write it out. Aluminum, oxygen. There we go. So which one does that? 2 atoms of aluminum, 3 atoms of oxygen is C. All right. All right, 15. Another symbol. SI is the symbol for, right? You just have to know it. That's silicon. Silicon. Do you know where to find silicon in the periodic table? Yeah, it's in the carbon group. Carbon, silicon. All right, 17. How many of the following did Dalton not discuss in his atomic theory? So we just say, count them up. Which ones, how many of these did Dalton not discuss in his atomic theory? Well, did Dalton know anything about isotopes? No. All right, so isotopes is one that he didn't talk about. Did Dalton know anything about ions? No, he didn't know ions either. Why? Well, one of the reasons was the subatomic nature of the atom had not been fully even discussed in the sciences. It wasn't until Thomson proposed that the electron originated in the atom that we even knew that there were subatomic particles. Dalton was before that. So Dalton didn't know about ions either. Right? Protons, electrons, neutrons, right? For the same reasons, protons, electrons, neutrons, Dalton didn't know anything about subatomic particles. So all five of them were never discussed in Dalton's atomic theory. As far as Dalton was concerned, the atom was just a jelly-filled bag. But each of those jelly-filled bags was unique for each of the elements. He did say that. He just didn't say how they were, why they were. So all five of those were never discussed by Dalton. All right, this next one takes a little bit of an assumption. Beryllium. The question is, how many neutrons are in beryllium? Well, first of all, let's find out how many protons were in beryllium. All right, so we look it up. Beryllium has 4 protons. Then we also look in that little square where you find Be, and there's an atomic mass. That's the average, the weighted average of all the isotopes of beryllium in nature. And we find that the value is 9.01. 9.01 atomic mass units average for beryllium. Now, what does that tell you? It tells you that most of the beryllium isotopes have a mass number of 9 because it's only slightly higher than 9. That means any other isotopes in there are skewing the weighted average atomic mass for beryllium toward the positive by just a little bit. So this one is the dominant isotope for beryllium. That's the deductive part of this question. Now that you know that, you can subtract 4 from 5, and it has 5 neutrons. That's the most abundant isotope of beryllium, has 5 neutrons. Now, if you want to skew it a little higher, you would need 6 neutrons, correct? Right, to make it go just a little bit higher, you need a very small amount of beryllium-6. But notice that that's not one of the options. Number of neutrons in beryllium-6 isn't even there. So that makes it easier, right? 5 is the answer. Which of the following is a non-metal? To answer this question, you have to know where the dividing line is between metals and nonmetals in the periodic table. And if you did the extra credit and you got that part of it right, then you know where that dividing line is. Let's see. Let me check the periodic table in the review document. All right. The periodic table that you have access to in the review document and subsequently in useful information for the exam, there is no dividing line given. You have to know where that line is. And that line starts between boron and aluminum. And goes down with silicon here. And we would have, let's see, silicon there, germanium here. Then goes over next to germanium is arsenic. And below that is antimony. Right? Keeps going down. That's the dividing line. Once you know where the dividing line is, you can look to the right and look for nonmetals. Which of these are nonmetals? Right? The only one in there that's a nonmetal is carbon. Carbon's up here, just above silicon. All right. What's the symbol for the element mercury? Uh, 23. If you have it memorized, you know instantly that the mercury symbol is Hg, which is actually an abbreviation for hydrogenium, which is Latin. And it means water making, water creating. Don't ask me why. There's probably a big story about that. Mercury was known from antiquity. All alchemists knew about mercury. And apparently it was used to produce water in some reactions. Symbol N stands for what? Well, each one of those elements listed, nickel, nobelium, niobium, neon, nitrogen, all of those start with a capital N, but only one of them stops with one N. That's nitrogen. Right? This is nitrogen. Now, just as parenthetically, if I said nitrogen reacts with hydrogen to produce ammonia, how would you write nitrogen? In that case, you would have to write nitrogen like this, because that's the way it exists in nature. And that's the way it exists when you react it with something like hydrogen. But N itself is the symbol. About 26. Choose the pair in which the components have the same charge. The same charge. All right. A hydrogen atom. What's the charge on a hydrogen atom? Let's do them one at a time. The charge on a hydrogen atom is 0. Right? If that's all you're given, that's it. Charge on an electron is negative. So those are not the same charge. How about an electron and a neutron? Right? Those are not the same. How about a neutron and a hydrogen atom? Yep, those are both neutral. Right? No charge at all. D is a proton and a hydrogen atom, right? That's no brainer. And proton and neutron, right? Okay, so this is the only one where it's neutral. The neutron is neutral because that's its nature. Hydrogen is neutral because it has a proton and an electron, which adds up to neutrality. But they both have the same charge. All right. 28. The number of protons in the nucleus of an atom is called its, this is just a definition. That's the atomic number. By the way, which came first? The atomic number or the number of protons? The atomic number came first. Let's see. Oh, my mind's gone blank again. Moseley. Right? Remember the story about Moseley? In, let's see, I think it was about 1912. He discovered the relationship between a formula. He has a formula, something equals something else, and there's a value in here times something else. And this value, he found that if he changed the number for each metal, it would give him the wavelength of the X-ray emission. He could measure the X-ray emission and then plug this number into his formula, and it would give him that value. They matched. This was the atomic number, he called it. Now, he didn't say that it was equal to the number of protons. He just said it was a whole number that was different for every element. Only later did we realize that that number is the same number as the number of protons. So historically speaking, the atomic number came first. The number of protons came next. '29. All right, which atomic particle determines the chemical behavior of an element? For this one, think about chemistry. What do we mean? Chemical behavior. The chemical behavior, think in terms of one atom approaching another. Are they going to interact in any way? Which would be a chemical behavior. They're going to interact with one another at what level? The first thing they see is electrons. Because of Rutherford's nuclear atom, you have protons and maybe neutrons in here. You have electrons out here, right? So when those two atoms approach each other, they see electrons first. That determines the behavior, right? So B is the answer. The behavior of an atom, chemical behavior of an atom is determined by electrons. Number 30. All right. What is the most abundant element on the Earth, including the crust, the oceans, the atmosphere? All right. We discussed this one earlier with the human body. It's oxygen. Oxygen is the most abundant element on the Earth, including the oceans and the atmosphere. Of course, the atmosphere is 21% oxygen. The oceans are made of water, mostly. Right? So there you have lots of oxygen there. And in the crust, oxygen is found combined with almost every other element. We don't find, in fact, the metals, we only find one, maybe three at most elements that can be found in pure form. Gold, yeah, obviously. Silver, sometimes you can find silver nuggets. Platinum, sometimes you can find platinum as a separate metal, but all the other metals typically are combined with oxygen. That's why we have to smelt them. We have to get them loose from oxygen, from their ore. 31. An atom with 15 protons and 16 neutrons is an atom of what? What do we need to know to find out? Do we need to know the number of neutrons to determine the element? No. All we need is the number of protons, the atomic number. 15 means that that one is phosphorus. All right, just look it up on the periodic table. Very simple. Do it in 10 seconds. $33. A certain isotope, X2 plus, okay? X with a 2 plus charge, contains 37 electrons and 73 neutrons. Okay? What's the mass number for this element? What do we need to know to determine the mass number? We need to know this number right here, the number of protons. If this atom has a 2 plus charge, what does that mean in terms of numbers of protons and numbers of electrons? It means you have more protons than electrons because that's where the positive charge comes from. you've got 2 more protons than you do electrons. That means you have 39 protons, correct? That's the only way that you can get a 2 plus excess for this atom. Now 39 plus 73 means 112 is the mass number. All right, 37. How many phosphorus atoms are present by 1 formula unit of cobalt-2 phosphate? And isn't that nice of them? Not only do they give you the name, they give you the formula. But I want to see if that formula is correct. Cobalt-2 phosphate. All right. This is a binary compound. We know it has cobalt, right? And we know that the charge on cobalt is 2 plus. We know it has phosphate in the anion position, PO4, which is a polyatomic ion. Your useful information will have a list of polyatomics and their charges. So you don't have to memorize it. You just have to recognize this as a polyatomic ion, right? There's no element in the periodic table called phosphate. So that's a clue. Look it up in the polyatomic ion chart. What's the charge? 3 minus charge. How do you get those charges to balance? Right? This is an even and that's an odd. So the easiest way is to cross multiply. Put the 3 over here. And with parentheses, put the 2 over here. And that will give you a 6 minus charge there and a 6 plus charge there. And they cancel. We're neutral. Now, why did I put a parentheses around PO4? Because polyatomic ions behave as a single unit. You cannot change the subscript of a polyatomic ion. If you need more than one of them, if you need more than 3 minus charge, then you have to use a parentheses. All right? So now we've got the formula correctly written. And we've confirmed that they did write it correctly in the question. So now the answer to the question, how many phosphorus atoms are present? You have 1 phosphorus atom per unit, but we have 2 units. So there are 2 phosphorus atoms. All right. 39. How many atoms are present by 1 formula unit of aluminum chromate? All right, so here we go again. Aluminum chromate. Right? Is that all we need in the name? Right? Is this a type 1 or a type 2 or a type 3 compound? Well, there's a metal in it, so it's either a 1 or a 2. What else do we need to know then to separate 1 and 2? Does this have a fixed charge or a variable charge? Aluminum is one of those elements. When it forms an ion, it always forms a 3 plus charge. Right? So this is a type 1 compound. We don't have to put the charge in there. That would be redundant. Right? So how about chromate? What is chromate? Right? Chromium is an element. Chromate is a polyatomic ion. And chromate is CrO4, right? With a 2 minus charge. So we have aluminum with a 3 plus charge. Here we go again. Odds and even. Put the 2 over here. Put the 3 over there. And that's written correctly. Now the question is, how many atoms are present in that formula? Total atoms. We've got 2 aluminum. We've got 3 times 1, 3 chromium. 3 times 4 is 12 oxygen. Right? So that's 17 atoms. All right, number 40. Which of the following statements are true? Okay. All right, so in order to do this one, you got to look at each one of those 4 statements. And find true or false. All right, first one. Models are always wrong unless they are proved by a theory. Well, models accompany a theory, typically speaking. So the model is dependent upon the theory. It's not proved wrong or right. It's just another way of expressing the theory, right? So one is not true, right? It's false. Number 2, Roman numeral 2. Elements such as lead are made of tiny particles that mostly consist of open space. As far as that goes, that's true. In fact, it's true of any atom. How about 3? The air you breathe is an example of a heterogeneous mixture. Right? What have I said over and over again? When you mix 2 or more gases together, you always get a solution, a homogeneous mixture, every time without exception. So this one is false. When you mix gases, you get a homogeneous mixture. And 4, because ammonia always contains the same relative number of atoms, it will always contain 4.6 grams of nitrogen for every 1 gram of hydrogen. All right, so here's what you have to do for that. Look at the molar mass. Let's see, we have covered molar mass, haven't we? I better check on that. Hold on a second. No, we haven't. That's the next chapter. All right. So if you have 1 gram of hydrogen, and 4.6 grams. All right, for this one, at this stage in the course, you have to assume that the ratio of 4.6 grams of nitrogen to 1 gram of hydrogen is true itself. And because ammonia always contains 1 nitrogen and 3 hydrogens, this is also consistent. The number of atoms ratio means that the mass ratio will also be consistent. And that goes back to the law of definite proportions. We have covered that. Law of definite proportions. And whose idea was that? That was Proust. All right. So these 2, a Roman numeral 2 and Roman numeral 4, are true. Number 42. Which pair have approximately the same mass? Approximately. They don't have to be exact. Approximately. Proton and neutron. How about that? Proton and neutron. Yeah, that's true. They're very close. Neutron's just slightly heavier. Electron and proton. No. Now, test taking technique. If you look at the multiple choice answers and there's a unique answer for each one, and there's nothing in there like two of the above, none of the above, all of the above, those types of inclusive or exclusionary type answers, then once you find your answer, you can stop. If you're sure that protons and neutrons have approximately the same mass, then you're done. Okay. So that would be the answer. If I stick in an answer like two of the above as the answer for E, then you've got to go through and look at every one of them to be sure that only one is correct before you can answer the question. (43). How many nitrogen atoms are indicated by the formula Al NO3? Taken 3 times, excuse me. NO2 taken 3 times. Right? How many nitrogens? Well, 3 times 1 is 3. Right? That answers the question. But I want to take it a little step further. What's the name of this compound? Is it type 1, type 2, or type 3? Right? There's a metal. It can't be a type 3. So, is this a fixed charge? We did one earlier. Aluminum is a fixed 3+ charge. So it's a type 1. That means all we have to say is aluminum. We don't have to say that. That would be redundant. Leave it out. This is a polyatomic ion. Look it up in your table. I mean, it's a dead giveaway. When you see a formula that's got a parentheses, that has to be a polyatomic. So this is nitrite. Right? It has a, let's see, -1 charge. This one has a 3+ charge. That's why you have 3 of these and only 1 of those. Aluminum nitrite is the name for this compound. (48). How many protons are in the atom carbon? This one, all you have to do is look it up in your periodic table. What's the atomic number? The atomic number for carbon is 6. That's the number of protons. You also have to know the symbol, of course. 51. All right, the symbol SN stands for what element? Is it sodium? No, we covered sodium earlier. It's Na, natrum. Sulfur? Sulfur is S. Strontium? Strontium is Sr. Tin? Tin is Sn. And silicon is Si. So the lesson here is you got to know your symbols. You don't know your symbols, you're going to lose a lot of points in this exam. And you won't be able to go any further in chemistry. If you don't know your symbols, you're going to be stuck. How about this one? 55. How many protons, electrons, and neutrons are in Sc, scandium, with a what? 2+ charge. Okay? How many protons are there? Well, you can't tell from the symbol. You have to look it up. It's in the periodic table. So Sc, scandium, says it has 21 protons. There you go. So 21 protons. What's the next one? Electrons. If you have 21 pluses and it has a 2+ charge, That means you have two excess positive charges. That means the number of electrons has to be 19. And the last is neutrons, correct? 21 from 45 is 24. 24 neutrons. So B is the answer to this one. 21, 19, and 24. All right. 61. The average mass of a boron atom is 10.81. 10.81 what? If we're saying the mass of an atom, it has to be atomic mass units. Because that's the only way we express the mass of a single atom. Well, not the only way, but typical way. You can convert that to grams, right? It'd be a very small number, but in this case, 10.81 means atomic mass units. Assuming you were able to isolate only one boron atom, the chance that you would randomly get one with a mass of 10.81, what's the probability? Of finding one atom with a mass of 10.81 atomic mass units? 0. It does not exist. This is a weighted average for the element boron. Right? Remember when we talked about counting by numbers? You need to know an average mass for your objects in order to weigh them and determine how many there are. That's why this is a weighted average. Right? A single atom of boron would be one value for one isotope, another value for another isotope, and their relative abundance would go into calculating that value. Right? So you will not find an atom with that mass. It doesn't happen. It will never happen. All right. This is 65. Which of the following elements is most similar to chlorine? When we say similar to, we're talking chemically speaking. So what elements are similar to chlorine? Well, everybody in its group, in that vertical column, is similar to chlorine. Fluorine, chlorine, bromine, iodine, astatine. Those all have similar chemical behaviors to chlorine. So you just look, which one of these is the right one? Bromine. All right. Oops, almost skipped it. 70. How many protons, electrons, neutrons are in this isotope of phosphorus? Right? Similar. We have to go to phosphorus on the periodic table and find the number of protons. 15. Right? So now, protons, electrons, neutrons. Protons is 15. We have a neutral atom, don't we? That means we have exactly the same number of electrons. And then 15 from 31 is 16. So 15, 15, 16 is the answer. C. $71. Which of the following contains the largest number of oxygen atoms? The largest number. A, B, C, D, and E, correct? Yep. So we have 4 H2O. We have O3. There's one of those. We have H2SO4. And we have 3 CO2. And we have AlNO3 taken twice. All right. Oops, excuse me, 3. Yeah, that's better. Okay, how many oxygen numbers are in each of these formulas? Well, 4 times 1 is 4, correct? This only has 3. This one has 4. This one has 2 times 3 is 6. This one has 3 times 3 is 9. So the last formula, aluminum nitrate, has the greatest number of oxygen atoms in that formula with the coefficient. This number is called a coefficient. There are 4 of those water molecules. So 4 times 1 is 4. 72. Aha. 72, you actually have to write the formula to answer the question. (72). So how many atoms of oxygen are in the formula unit of calcium dihydrogen phosphate? Calcium dihydrogen phosphate. All right. This is not an element. This is a polyatomic ion. Look it up. What is the formula for this one? It's dihydrogen phosphate, and then the charge. You'll find the charge in that table also is -1. Calcium is an alkaline earth. Every time it ionizes in a compound, it forms a 2+ charge every time. So this is a type 1 compound. That means you don't have to say what the charge is. And it didn't say right there. We know what the charge is. It's not redundant. All right, so how do we balance this one? Well, we need 2 negatives to balance 1 2+. So that's the formula. Of course, when you write the formula, you don't have to put the charges in. So 1 calcium and then the phosphate. So the question is, how many oxygen atoms are there in that formula? 2 times 4 is 8. 8 oxygen atoms in the formula. (75). Which of the following statements are true? So we've got 3 possibilities here. All right, let's look at number 1. The number of protons in an element is the same for all neutral atoms of that element. Is that true? Yeah. Yeah, the number of protons is always the same for atoms of an element. Okay, so this one's true. All right. How about number 2? The number of electrons in an element is the same for all neutral atoms of that element. Yeah, if they're neutral, then the number of protons equals the number of electrons. And we've already said the number of protons is equal for each atom. So if it's neutral, the number of electrons has to be the same also. Number 3, the number of neutrons in an element is the same for all neutral atoms of that element. False. Why? Isotopes. Right? So Roman numeral 1, Roman numeral 2 are the only true parts. B is the answer. Only 1 and 2 are true. Let's see, 76. The correct formula for carbon monoxide. Haha. Type what? It's got carbon and it's got oxygen. Those are nonmetals. This is a type 3 compound. That means we can't balance charges. We have to say how many there are. Carbon means there's one. Monoxide means there's one. CO is the formula. All right. Simple as that. Just learn the rules and practice them. 77. Which of the following is a binary compound? Well, first of all, this is one of those questions where I like to work backwards front to the front. Which ones of these are compounds? Right? A, B, C, D, E. A, B, C, D, E. Let's just write them in here. This one, H2SO4, H2SO2, and HCN. Now, what we're looking at here is binary compound based upon your author's, Zumdahl, the author's definition of binary. Their definition of binary is only two elements. My definition expands, but binary compound to them is only two elements. Right. First of all, which ones are compounds? Right. That's a compound. That's a diatomic element, right? Throw it out. So now we just need to find out which ones are binary. Well, this one has three elements. This one has three elements. This one has three elements. This one only has two elements. So by your author's definition, the correct answer is C. That's a binary compound. It only has two elements in it. All right. Let's see, 79. The correct name for an aqueous solution of HC2H3O2. HC2H3O2. Well, first of all, what is that? It's an acid. If you put it in water, the hydrogen that's first means it's an acid. Then what we have to do is say, what is this? This is a polyatomic ion. Look it up. This is acetate. So if it were not an aqueous solution, it would be hydrogen acetate. Now, when we name an acid, though, H there, aqueous there, when we name an acid, what else do we look for? We look for oxygen. There's an oxygen here. So what do we not say? We do not say hydro. We don't say hydro. What we do is take the ending, ates become ix. So instead of acetate, it's acetic acid. That's it. Okay. Number 80. Na plus represents what? Well, for one thing, it's derived from sodium, correct? But it also has a charge. So not only is it sodium, it's an ion. And sodium is an alkaline metal. When it charges, it always makes a +1 charge. So all we have to do is say sodium ion, and we know that it's this and that only. It can't be anything else. Right? So this is unambiguous and not redundant. All right, 81. Hg2 plus. All right. This is that weird one. All right, Hg. You know what Hg is? Mercury. Well, first of all, is mercury eligible for multiple charge? Yeah, it can have more than one charge. But with mercury, it's either this or this. Right? It's always 2 plus, but this 2 plus has 1 mercury and this one has 2. So that means this mercury atom, individual atom, has a 1 plus charge. Since it's multiple possibilities, we have to say what it is. So this is an ion of mercury with a 1 plus charge. Not that one, this one. That's why B is the answer. It's the only answer. You have no other choice. 82. What's the correct name of the compound that results from the most stable ion for sulfur? And the metal ion that contains 24 electrons. With 24 electrons in this one. So what they're trying to do is to prompt you to determine what M is, the metal, based upon the charge of the anion. So we're working backwards in a balanced formula. What is the most common charge for sulfur? Well, where is it in the periodic table? It's in the second group over, well, actually the third group over. The first group is the noble gases, right? Then you have the halogens, and they're always -1. Then you have the chalcogens. Right, we start with fluorine here. We start with oxygen here, and these are always -2. Oxygen, sulfur, right? So sulfur is a -2. So they don't actually tell you there's only one metal ion. We have to assume that there's only one metal ion. This would have to be 2 plus. So if we want to find out what that is, we need the number of protons. This is 2 plus excess. So that means we have 26 protons to give us a net charge of 2 plus. Now we can find out what it is. 26 is iron. So our compound is FeS. But we have to name it also. If this is a 2 plus charge, iron, and it's a type 2 compound because iron can have variable charge. So we say iron 2 sulfide. Okay, not sulfate. Sulfate is a polyatomic ion. Sulfide is the ending for this one. That's why D is the answer. All right, 83. The symbol for the rubidium ion. So you go find where is rubidium. Rubidium happens to be an alkali metal. And its symbol is, and all alkali metals, when they form ions, are +1 charge. Right? So that is D in our answer list there. That's all it can be. There's no other possibility. 84. What is the correct formula for barium hydroxide? Barium, right? And hydroxide. A polyatomic ion with a -1 charge. What's the charge on barium? Barium is an alkaline earth. it's always 2 plus. That means we need 2 of those to balance the charge. So E is the answer, the one and only. 85. The correct formula for lead-4 nitrate. All right, this is a giveaway. This has to be a type 2 compound. Lead with a 4 plus charge, and nitrate is a polyatomic ion. Look it up. It has a 1 minus charge. So that means we need 4 of those. Pb, NO3 taken 4 times. That answer is D. Right? 86. 86. The name for the acid, HNO2. So we're going to name this with the acid convention. That means it's in aqueous solution. All right. So first of all, it has oxygen. So what? No hydro. We look at this. What is that? That's nitrite. And ites become us. So this is nitrous acid. Right? That's D. The correct formula for the ammonium ion, 87. Ammonium ion. There's no element in the periodic table called ammonia. Ammonium is a polyatomic ion that you'd have to look up if you don't have it memorized. And it's going to have this formula and that charge. Right. 88. The name for AlOH3. Right? Type 1, type 2, type 3. There's a metal there, so it's either 1 or 2. Aluminum has a fixed charge, so it's a 1. All we have to do is say aluminum. And then what's OH? Well, the parentheses should be a giveaway. This is a polyatomic ion. Look it up. So OH minus is hydroxide. Right? Let's see. If you've ever had a sour stomach and taken drunk the liquid Mylanta, Mylanta has aluminum hydroxide in it. It has other things, but it does have aluminum hydroxide. And it's very effective at neutralizing stomach acid. So that would be A. We don't say aluminum 3 hydroxide because aluminum can only have 1 possible charge. So C would be redundant. A is the correct answer. 89. The correct name for an aqueous solution of HCN. HCN in aqueous solution. All right. This is an acid, and there's no oxygen. So we start with hydro. Right? That's a polyatomic ion called cyanide. And in this case, ides become X, hydrocyanic acid. That would be D is the answer for this one. 91. Which of the following is named correctly? Well, we have unique answers, A through E. That means we can work our way down, and when we find the correct answer, We can stop. So how about A? Is HCl aqueous solution hypochlorous acid? No. HCl has no oxygen in it, so it starts with hydro. Hydrogen chloride, ide becomes ic, so it's hydrochloric acid. That one is false. How about B? HNO3, is that nitric acid? HNO3. NO3 is nitrate. There's oxygen there, so we don't say hydro. We just go straight to this one, nitrate. 8 becomes ic. It's nitric acid. This one is true. We found our answer. 92. All right. The substance ClO3 minus. You may recognize that as a polyatomic ion, right? It's not a polyatomic molecule. It is an ion. It's a polyatomic ion, chlorate. Right? Polyatomic ion. B is the answer. That's it. Nothing else possible. 97. I think we're going to finish today. We'll finish the whole thing today. Sodium chlorite has the formula of what? Well, we know it has sodium in it, right? Sodium. And chlorite. What is the polyatomic chlorite? ClO2 minus. Right? So we know sodium is an alkali metal, always has a +1 charge. Chlorite is a fixed charge too because it's a polyatomic ion. ClO2 minus, one of each is all we need. So NaClO2, A is the answer. 98. All right. Correct name for an aqueous solution of H2SO4. H2SO4 in aqueous solution. All right. Oxygen, no hydro. So we go straight to the polyatomic ending. Sulfate, 8 becomes ic. So we have sulfuric acid. Right? B is the answer. How about 101? The formula for the compound formed from the polyatomic ion ammonium and phosphate. This one's easy, right? All you have to do is balance the charges, right? This is a 1 plus, that's 3 minuses. We need 3 pluses to balance the 3 minuses. So A is the answer. Let's see, 103. The correct name for an aqueous solution of HCl. Aqueous solution. Right? So now we're talking about acid. There's no oxygen, so we have to say hydro. And this chloride, hydrogen chloride, in aqueous solution now becomes, I becomes ic, hydrochloric acid. Okay? That's D. 105. The compound PI3 is named Type 1, type 2, type 3. They're both nonmetals. So it's a type 3 compound. We just say how many there are. Since phosphorus comes first, we don't say monophosphorus, we just say phosphorus. Phosphorus. Then 3 iodines. Right? Iodine becomes iodide. Tri iodide. There it is, the first one. Phosphorus triiodide. That's 105. 107. We're going to name this what? That's an ion. So the ending has to be an ion. But where does lead come from? It comes from a region of the table that has metals in it with multiple charges, possible, variable charge. So that means we have to say lead 4, oops, lead 4 ion. C is the answer. 111. What is the formula for selenium trioxide? We have to know the symbol for selenium. It's right below sulfur. Right? So selenium, being a chalcogen, is a 2- charge. Oh, 1 second. Selenium trioxide. Those are both nonmetals. Selenium's not, it doesn't have a charge. Trioxide is like that. So selenium trioxide is just SeO3. That's all it can be, SeO3. $115. Which of the following compounds is not named as an acid? All right. Let's see. First one is HCN, aqueous. Would we name that one as an acid? Yeah. Yeah. It has hydrogen. It's an aqueous solution. How about this one? NH3, aqueous. That one has no leading hydrogen. This is not an acid. In fact, this is a base. This is a base. So this one would not be named as an acid. We found our answer right there. Just for information, the rest of them would be named as acids. They all start with hydrogen. We'll talk about acids and bases later. Right now, we're just naming them. 117. What's the formula for gold 1 oxide? Gold 1 oxide. Well, first of all, is that correct? Can gold have variable charge? Well, let's see. Yeah. Gold comes from the transition metals, and it's not zinc, cadmium, or silver, which have fixed charges. All right, so gold can have more than one charge. So this is correct, gold 1. Au, aurum, is gold. It has that plus charge. And oxygen always has a 2- charge. So that means Au2O is the correct formula. C is the answer. 121. The carbonate ion has the formula CO3 2-. Look it up. That's correct. What's the correct formula for sodium carbonate? Sodium can only have a 1+ charge. So sodium carbonate with a 2- charge means we need 2 sodiums to balance the charge. So the answer is E, Na2CO3. (124). Which of the following represents the hypochlorite ion? Remember that list I gave you. Chlorate, chlorite, hypochlorite. ClO- is hypochlorite. You can look it up if you want, but that's the way I do it. 125. What is the formula for calcium hydroxide? Right, we know we have calcium. We know we have hydroxide, polyatomic ion with a 1- charge. How about the charge on calcium? Right, is this a type 1 or a 2? Calcium is an alkaline earth. It's always a +2. That means we need 2 of them. So CaOH taken twice. E is the answer. What's the name for HBRO aqueous? 127. HBRO in aqueous solution. Well, we got an oxygen, so we know we don't start with hydro. All right, so what is this? Remember, we just did a question called identifying hypochlorous. All we have to do is substitute Br, that's hypo. Bromide, hypobromide. That's hypobromide. So Ike becomes us. Now the name of the acid is hypobromous acid. Which is B, hypobromous acid. How about 128? The name for the H2SO3. H2SO3. That is sulfite. There's oxygen, so we just say it becomes us. Sulfurous acid. That's B. 129. P2O5. You want us to name that one? Yep. Type 1, type 2, type 3. Type 3. Phosphorus and oxygen are both nonmetals. So we just say di for 2, diphosphorus. Phosphorus. Pentoxide. There we go. So that would be E, diphosphorus pentoxide. Okay. 132. Correct. Yeah. Correct formula for silver iodide. Well, we got silver, argentum, which is always a +1 charge. And iodine, which is a halogen, it's always a minus charge. So AgI is it. That's the formula for silver iodide. How about lead 2 sulfite? or 140. Lead 2 plus, sulfite SO3 2 minus. Okay, that's it. PbSO3. PbSO3. E is the answer. 142. The correct formula for the carbonate ion. We were given that in the previous question, weren't we? You can look it up. CO3, 2 minus. That's the carbonate ion. 143. A compound containing an unknown ion, X, has the formula XCl2. XCl2. Now, we're not told whether that's a metal or a nonmetal until the second statement, ion X. It has to be a metal because nonmetals don't form ions in the first position, right? So this is a metal, right? X contains 20 electrons. Okay? What's the charge here? Well, -1, that means a total of -2. So that metal has to balance -2 with only one of them, because it says the formula is a ratio of 1 to 2. So this one has to have a 2 plus charge. That means 22 protons. Okay. What is the identity of X? 22 protons means titanium. But titanium is charged. So the correct answer is Ti2 plus. A is the answer. 147. The name for NaHCO3. NaHCO3. Well, that's sodium. Right? Right? What is this one? Look it up. Hydrogen carbonate. Right? Sodium hydrogen carbonate. Parenthetically, bicarbonate. That's a trivial name, we call it. It's not standardized. So this trivial name substitutes for this part bi. So sodium bicarbonate is the same thing. And you can buy it off the shelf. Arm & Hammer. Sodium bicarbonate. It's reasonably pure also. Right? So there's the answer. Put it in your biscuits to make them rise. That's a chemical reaction. 148. The correct name for the aqueous solution of H2CO3. H2CO3 aqueous. All right. We don't say hydro because why? There's an oxygen. What is this? That's carbonate. So we go straight to this one. 8 becomes ic. This is carbonic acid. Sounds bad, doesn't it? Well, this carbonic acid is in every sip of pop that you take. That's where the fizz comes from. Carbonic acid. All right, another compound name. 153. NH4, Br. So NH4 is ammonium. We say ammonium. And there's no need to put the charge in there because polyatomics have fixed charge. This is a type 1 compound. And this part of it is bromide, ammonium bromide. Right? If you put the charge in there for ammonium, that's redundant. A is a wrong answer. C is the correct answer. 155. The formula for the compound formed from ammonium and sulfate. So ammonium is like this. Sulfate is like that. Oops, sorry. Too many charges. 2 minus. So we need 2 of these polyatomics to balance that sulfate. So let's see. D is the answer. NH4 taken twice, sulfate, SO4. That's it. So we finished the review for exam 2. That means this is Thursday. Next Tuesday, you can Zoom back in if you want, and I'll be here for questions and answers on next Tuesday. And the following Thursday, which is the 8th of February, is when exam 2 is due. All right, so you can take it in person or you can take it in Brightspace. And that's it. That's the review for chapters 4 and 5, exam 2.